Howdy, 7th grade. Today we're going to look at how to solve some equations that involve exponents. So first we're going to do a quick review on how we solve normal equations, then we'll go into this exponent thing. So starting off with a bit of a review, if I have the equation 3x plus 5 equals 20, what I'm going to want to do, my goal is to get x alone. So I want to get this x alone, and the way I'm going to do that is by looking around it, seeing what is happening to it, and then doing the opposite of that. So I can see that there's addition here. So because I see addition, I'm going to want to subtract, because subtraction is the opposite of addition. All right, I'm adding 5, I'm going to subtract 5 to get that to cancel out. And if I do it to one side, I have to do it to the other. So I'll end up with 3x equals 20 minus 5, which is 15. After that, I know that there's multiplication going on here, so I want to divide by 3. And because multiplication is the opposite of division, these will also cancel out, and I'll end up with x equals 5. Which is fairly simple. We've done some of these before, but we're going to make it a little bit more complicated today, because we're not just going to have multiplication and addition, we're also going to have exponents, which are going to make our life a little bit more fun. So if I have something that says x squared plus 3 equals 28, x squared plus 3 equals 28. So this is a real one. What I'm going to want to do first is try to get x alone. So my goal is to always get x alone. So looking at this whole equation, the thing that would be easiest to get rid of is going to be the addition, always going to be the addition. So because the opposite of addition is subtraction, I'm going to subtract, and I get x squared equals 25. So now the question becomes, what squared is 25? Well, we kind of know the answer to this, probably, but I want to make sure that we're very, very careful when we do this. And the reason being is if we have a squared, x squared equals something, we need to end up with x equals, and this is the very, very important part, positive or negative square root of that number. So we know that the square root of 25 is 5. So this would give me x equals positive. That's not how you write positive. There we go. Positive 5 or negative 5. So x would equal positive 5 or negative 5 there. And that's why we have to make sure we have this plus or minus symbol. This is the plus or minus symbol, which I don't think should come as a surprise, considering it's made up of a plus and a minus. And when I start talking, I start writing things wrong. There we go, the plus or minus symbol. This tells me that x is equal to positive 5 or negative 5. So we're going to try that one more time just to see what happens. And in the second example, we're going to have x squared plus 27 equals 36. So if I'm trying to get x alone, what I should do is to subtract 27 from both sides, and I get x squared equals 9. So to get rid of the x squared, I have to think, what is the opposite of squaring? And the opposite of squaring is going to be the square root. And we know that when we do that, what we're going to need to do is to square root x squared equals plus or minus the square root of 9. And this plus or minus part is going to be very, very important. Don't forget this, because otherwise you only have half the answer. So the square root of x squared is going to be x equals plus or minus the square root of 9. I know the square root of 9 is 3. So I have positive 3 or negative 3. And that's basically it. So we're going to be doing the same thing we've been doing with all of our equations, except now sometimes we'll have to take a square root. So I want to do one more quick problem with y'all. So if I have 3 x minus 2 squared plus 5 equals, and this is going to be 53, I believe. What's going to end up happening, just so that we can work on a hard problem, this is kind of the challenge problem, is what I'm going to want to do is to get this whole thing, my entire square root there by itself. So I'm going to start by subtracting 5, because that seems pretty easy, and I'll end up with 3x minus 2 squared equals 53 minus 5 is 48, after which I'm going to want to divide by 3, and I will get x minus 2, the quantity squared, equals 48 divided by 3, and 48 divided by 3 is going to be 16. I can now take my square root, and I get x minus 2 squared. The square root of that equals plus or minus square root of 16, which is going to be plus 4 or negative 4. I'm going to split that up because I know the square root of x minus 2 squared is x minus 2. So x minus 2 now has to equal either positive 4 or negative 4. So if I add 2 to both sides, I would get x equals 6, or on this side, x equals negative 2. So x equals 6 over here, x equals negative 2 over there, and just like that, we are all finished. So I know that's a little bit crazy, the challenge problem there, but I think that if we look through it, we know how to do all these steps. The trick was to start by isolating this. So isolate the squared part first, and then after that everything else kind of falls in line, and we end up with our two answers. So that's all I got for y'all today. I hope you have a great day, and I'll see you tomorrow.